All right, we're going to talk about the flow of the cerebrospinal fluid through the brain, obviously. Okay, so this is the brain. These are two different views of the brain. What you've got here highlighted in blue are the ventricles. These are the main places where cerebrospinal fluid is going to be inside the brain. Now, there's another place outside the brain called the subarachnoid space, which we've talked about. It's part of the meninges that we'll talk about later. But for right now, we're going to focus on these ventricles right here. Okay, so let's take a look just from this side view here. The first thing that I want you to know is this little area right here. This is the choroid plexus. And this is actually what produces the cerebrospinal fluid. All right, so what happens in the choroid plexus is you have these ependymal cells right here. And their job is to filter the blood, just regular, everyday blood, good old blood. And these ependymal cells will filter the blood into cerebrospinal fluid. So some of the nutrients that are in the blood are able to pass through the ependymal cells and become the cerebrospinal fluid, but not everything in the blood passes through. So we've talked about the blood-brain barrier, and these ependymal cells in the choroid plexus help preserve that barrier. Okay, so this choroid plexus here in the lateral ventricles produces most of the cerebrospinal fluid. It doesn't produce it all. You can see that there is another choroid plexus in the third ventricle here and another choroid plexus in the fourth ventricle down here. I should say that this one here, this choroid plexus in the lateral ventricle, there are two lateral ventricles. We're looking at the left lateral ventricle right now, but there is one on the right. So there's going to be two of these shapes, one left and one right. This is a central third ventricle and central fourth. So there's four of these main choroid plexus altogether. Okay, so let's trace the flow of cerebrospinal fluid. So it's gone through the ependymal cells. The blood has been filtered by the ependymal cells to create cerebrospinal fluid. We're going to trace it from that first choroid plexus that we were looking at. It's going to come out into the lateral ventricle, and it's going to fill up the inferior horn down here, inferior horn of the lateral ventricle. It's also going to fill up the posterior and anterior horns of the lateral ventricles. And once it's all filled up in there, it's going to move on. It's going to go down the interventricular foramen into the third ventricle. There we go, the third ventricle. There's this little area in the middle of the third ventricle that kind of makes the third ventricle look a little bit like a seahorse head or a donut, sort of. And that's called the interthalamic adhesion. So what is the interthalamic adhesion? Well, it's a little bit like the corpus callosum that we've talked about. The two hemispheres of the brain are connected by the corpus callosum. It's the major pathway to share information between the two hemispheres of the brain. And the two halves of, the two thalamic halves have one of these as well. That's the interthalamic adhesion. So what you're seeing here, these are two halves of the thalamus. And just like the brain, they're mostly independent of one another, but they do have a pathway to convey information between the left and right halves. That's the interthalamic adhesion. So the interthalamic adhesion here, the third ventricle is around the interthalamic adhesion, so it's between the two halves of the thalamus. But that's why there's that little donut shape to the third ventricle. Okay, so now after the third ventricle, the cerebrospinal fluid is going to flow down the cerebral aqueduct towards the fourth ventricle right here. And once it reaches the fourth ventricle, it's got two possible pathways that it can take. One is that it can leave the ventricular system altogether. It's going to exit through the foramen of Magendie, which is just one central aperture out into the subarachnoid space, or it can come out of the foramina of Luschka, which there's two of. They're both lateral. So you've got three main apertures for cerebrospinal fluid to enter the subarachnoid space. The other option is for the cerebrospinal fluid to continue flowing down. The cerebral aqueduct becomes the central canal all the way down the spinal column, the spinal cord. And it's this little central canal is just a small little kind of straw, fluid-filled straw of cerebrospinal fluid that goes all the way down the gray matter of the spinal cord. Now that's kind of a dead end. The cerebrospinal fluid is going to flow down through that central canal, and it'll flow back up to, be gotten rid of once it's become a waste product. So there's not much more to talk about there. However, if we follow this first tract out the foramen of Magendie and the foramina of Luschka, then we've entered the subarachnoid space. So what happens in the subarachnoid space is the cerebrospinal fluid is kind of moving all around the brain now. So we're outside of the ventricular system, which runs through the innards of the brain, and now we're on the outside of the brain. So here, well, and importantly, we're also on the outside of the spinal cord as well. So remember the arachnoid layer of the arachnoid mater and the pia mater and the dura mater are not just around the brain, they're also around the spinal cord. So the subarachnoid space is not just around the brain, but it's also around the spinal cord. So the subarachnoid space then moves throughout, is located throughout both of those systems as well. So the cerebrospinal fluid is going to move through this subarachnoid space around the brain and also around the spinal cord. So you can see down here, it moves all around the outside of the spinal cord. It both cushions the spinal cord from impact, and it can remove waste products as well, which is one of the other things that it's doing on the outside of the brain. One interesting thing that it does for the brain as well is that cerebrospinal fluid is very buoyant. So it actually allows the brain to float inside this bath of cerebrospinal fluid. Without cerebrospinal fluid, the brain would be so massive that it would kind of smother itself under its own weight. So it kind of remains mostly weightless, not entirely weightless, but more weightless, bathed in this cerebrospinal fluid. And so that's helped by this subarachnoid space that allows it to move all around the outside of the brain. Okay, so the cerebrospinal fluid is circulating around the spinal cord and around the brain. But what's the next step? Well, it moves upwards toward these little pouches here. And these little pouches are called the arachnoid granulations. So these kind of act like valves, one-way valves. Cerebrospinal fluid can exit them, but nothing outside can come back in. So this is like the end of the line, basically, for the cerebrospinal fluid. When it's done, it's carrying all of its waste products out. It's moving out through these arachnoid granulations into this dark blue space, which is the superior sagittal sinus. I haven't drawn this exactly to scale because it's the superior sagittal sinus here is a lot smaller than it is as you move towards the back. It gets larger, kind of like a triangle, sort of, if you think about it. So it's very, very small over here and gets larger as it gets towards the posterior end of the brain. Why is that? Well, mainly what's moving into the superior sagittal sinus is old cerebrospinal fluid. And if it's starting to come out here, you've got more and more arachnoid granulations as you move, so that's why the space has to be larger. So the superior sagittal sinus moves back towards the posterior side of the brain, and here at the very end of the sagittal sinus, it's going to return to venous circulation. So the cerebrospinal fluid just kind of empties back out into the bloodstream. So it's a complete cycle, right? We started with blood going into the ependymal cells, which then got filtered into cerebral spinal fluid. It moves through the lateral ventricles, which you could think of them in a way as the first and second ventricle, but we just call them the lateral ventricles. Then it moves into the third ventricle, right? So if this is first and second, then you've got third, but we'll call them two lateral ventricles. Then you go to the third ventricle, down the cerebral aqueduct to the fourth ventricle, either down the central canal or out into the subarachnoid space, up out of the arachnoid granulations, into the superior sagittal sinus, and back to the blood. So it's a complete cycle, right? And it's actually blood pressure that's going to kind of cause more blood to go towards the ependymal cells and then circulate through this system, this ventricular system, the cerebral spinal fluid system. All right, well, that is the end. That's everything you need to know about the flow of cerebral spinal fluid.